Today's lesson is an algebra review of solving equations and function notation. So in order to solve equations, we need to first know what an equation is, and it's a mathematical statement that shows two expressions are equal. To solve an equation, you need to isolate the variable or get y by itself. Using inverse operations. Let's see, what are some inverse operations? Adding and subtracting are inverses, multiplication, and dividing. Okay. Just a hint, how do we know which one to get rid of first? So when we are solving, we want to get rid of the operation that is the furthest from the unknown variable first. Okay, so let me show you what I mean. So first off, I'm not talking about like physically the 11 is the furthest away. I'm looking at only the left side right now because I'm trying to get x by itself, and there's a 3 and a 2 that I need to get rid of eventually in whatever order. So if you take a look, the 3 is stuck with the x, so we know we want to subtract 2 first. Because an opposite of positive 2 is negative 2. I like to cross things out to keep things neat. And then we have 3x equals 11 minus 2, or 11 plus negative 2 is 9. Right now, 3x is something that a lot of students just like read out. 3x equals 3 times x. So that means we need to divide because that's the opposite of multiplication. So then we get x equals 3. If you wanted to check and make sure that your answer was correct, okay, let's say you're just not sure, you would take your 3 and plug it back in to the original equation where x is. So that would be 3 times 3 plus 2 equals 11. Now don't do the same things here, because if you made a mistake here, you'll make that same mistake here. So what you want to do now is just simplify. What do you see that you can do? Right now we know that 3 times 3 is 9 plus 2. And the question is, does it equal 11? And yes, 9 plus 2 is 11 equals 11. Okay. So the second example looks slightly different, but it's still the same idea. I'm trying to get x by itself, and we need to circle what's stuck with it right now. And that means I get rid of this negative 4 or minus 4. And we add 4 to get rid of it. And I cross it out as soon as I've gotten rid of it. Then I have 2x over 5 equals 7. Okay, so I'm going to do the same thing. I'll circle what's stuck with the x. And right now, that's 2. Now, 2x over 5 sounds like 2x over 5, right? But it's really 2x over 5 is the same as 2x divided by 5. So how do we get rid of a division problem? We multiply. So now I have 2x equals 35. And this is where students freak out because, oh my gosh, Ms. Trey, I cannot divide 35 by 2. Well, that's perfect, because if you can't divide, you stop. And x equals 35 over 2. Okay. You'll notice that example 3 and 4 are actually the exact same problem, and I'm going to do it 2 different ways. The first way that most students do it is they distribute and they multiply, because 3 groups of x plus 2 is 3 times x plus 2. So I'm going to multiply, there's 3 x's and there's 3 groups of 2. So that means I have 3x plus 3 times 2 is 6 equals 15. Okay, I'll draw my line now. Circle my 3 and the x because they're stuck together. And I'll do minus 6, bring down the 3x, That gives me 9. Divide by 3, divide by 3, and I get x equals 3. Okay. Now example 4 I'm going to do slightly different. Instead of multiplying by 3, let's pretend that my x and 2 are stuck together right now, and I want to get rid of that 3, which I said was a multiplication problem. So in order to get rid of it, I divide by 3. Now you can imagine that this type of division only works if the number here on the right side is divisible by 3. Right? So this is why most teachers don't teach this method in example 4. They teach number 3. Because no matter what, if this was like a 14, I would be fine and I'd just end up with a fraction here. But if this was 14, then I would have to work with fractions and subtract 14 over 3 minus 2, which is really messy. So instead of that, luckily my number can divide. But watch what happens when I divide. Look how much shorter it is. Like the numbers got smaller, there was no big numbers, I didn't have to worry about distributing correctly, and now all I have to do is subtract 2 on both sides, and my x is by itself already. I really like x equals 3 apparently. Hopefully that's a good solving equations review. This is just 2 to 3 steps, nothing too complicated. Now let's talk about function notation. Function notation is simply another way to write functions that allow you to name multiple functions. So let's say in one problem I had y equals 2x, y equals absolute value of 2x plus 1, y equals t squared, and y equals r squared plus 3r. And I said y equals 5. How do you know which one I'm talking about? Right? You wouldn't. So what we're doing is here, we're going to use something on this side called function notation, which is this f of x. Notice I didn't say f parentheses x parentheses. I said it as f of x. Say that out loud to yourself as you watch this video. F of x. Okay. The more confident you are when you speak, the better you feel in a class if you have to speak. F is the name of the solution function, and f of x, the whole thing, is the output, or y values. Right? Like f of x is just a fancier way of saying y equals 2x. Notice that any variables can be used. So let's start with f of x equals 2x. And all I did was replace y with f of x. But we're doing this in the same problem, so now let's use a different variable. G of x equals absolute value of 2x plus 1. We'll talk about what absolute value is later. And then let's go h of x. Ooh, dangerous. We don't want to do h of x if there's a t. Okay, so if there's a t, we'll use t. H of t equals t squared. And this last one, you can take a moment and try it yourself. Pick any variable, see if you can write it. I don't know, maybe I'll use like m of r equals r squared plus 3r. So the important thing to remember is that f of x is just another way to write y. Okay, excuse me, sorry, it's my go home alarm. Okay, so for example, let's take a moment and see if we use different variables. Distance as a function of time. Okay, so if distance as a function of time is what we're trying to write, then we can use d for distance. As a function of is parentheses, right? Like we said, f of x. And of time, we can use t for time. Let's now evaluate some functions given the input. Okay, that means given x, I'm going to plug in and find y. First thing you should do is read the directions. Evaluate the following expressions given the function g of x equals negative 3x plus 1. When I read that out loud, it means that I'm not going to forget that negative. On a test or a quiz, your brain just skips really fast. So read it to yourself in your head. You guys see it here that says g of 10? Well, we used to write it as g of x. So does that give you an idea that 10 is x? Okay. So that means I'm going to take this function, negative 3x And instead of x, I'm going to replace it with parentheses 10. Don't forget the plus 1 at the end. And now all we're doing is simplifying. Negative 3 times 10 is negative 30 plus 1. And if I owe someone $30 and then I get $1 back, or pay $1 back, then I only owe $29. Before you box this, it's best to write g of 10 equals negative 29. So now it tells you what function I plugged into, what I plugged in, and what I got out. Okay, so let's try this. Maybe take a moment and try this yourself. You can pause the video if you want. So we'll do the same function. G is negative 3 times x, which is negative 2 now, plus 1. And so negative 3 times negative 2 is positive 6 plus 1. And we have g of negative 2 equals 7. Let's keep going. Flip your page over. Example 6 is more of the same. If you read the directions, they're exactly the same, except my function is now a little bit more complex. So I have f of x equals x squared plus 2x minus 7, and now I have f of 5. Well, this used to be f of x, right? So that means x equals 5. And so let's write this in. I have 5 is my x. I'm going to square it, plus 2, parentheses x, which is 5, then minus 7. So the only difference is that if there's 2 x's, then you write it in 2 times. What is 5 squared? Ooh, dangerous. Please don't tell me it's 10. Okay, it's not 5 times 2. 5 squared means there's 2 5's. So it's 5 times 5, which is 25, plus 2 times 5 is 10, minus 7. And then that's 35 minus 7, which is 28. Okay, and it's f of 5. Let's do the same thing over here. So I'll plug it in. I'll have negative 3 instead. And instead of x, I'm going to put in negative 3. Well, here, let's write this. It's 2 negative 3's. Okay, so this is really dangerous. On your calculator, if you do negative 3 squared on your cell phone, it's going to tell you this is negative 9. Because it's negative times a 3 times a 3. There's only one negative. And your calculator will automatically do this part first. That does not equal negative 3 squared, which is negative 3 times negative 3, which is positive 9. You guys see the difference? Okay, so here I'm going to write negative 3 times negative 3. That's going to be positive 9 minus 6 minus 7, which is 3 minus 7, negative 4. The next two are exactly the same, just with a division problem instead. Okay, notice I didn't say fraction problem. It's a division problem. 12 divided by x. So h of 6, that means I'm going to have 12 divided by 6, because this is h of x, so x equals 6. And then we have 12 divided by 6 is just 2. So this one will be pretty straightforward also. 12 divided by negative 3, which is negative 4, h of negative 3 equals negative 4. We're going to go into slightly different problems here. So if I read the directions carefully, don't just take the 10 and plug it in. The 10 is no longer given as like g of 10. This says g of x equals 10, and we need to solve for x given this function. So if g of x equals to 10, remember g of x is the same as y. That means here we're going to plug in 10 for the whole thing. And so I'm going to have 10 equals negative 3x plus 1. And notice it's a totally different problem. Instead of simplifying and just adding, subtracting what I see, I now need to use inverse operations to get x by itself. Circle what I want, cross out what I don't. So positive 1 is canceled by negative 1. Negative 3x is negative 3 times x, so I'm going to divide by negative 3. If I didn't do negative 3 and I just did 3, notice you'd still have a negative left over, so I'm going to cross out both. And because there's a negative left, I know my answer is negative 3. Okay. Typo here was a little confusing for students in class. Please take a moment and add the letter f. So solve for x given the function h of x equals x over 4 plus 5 if h of x equals 9. Well, if h of x equals 9, then that means here this is also 9, right? So we can have 9 equals x plus divided by 4 plus 5. I'm going to circle what's stuck together, subtract what's not. That gives me 4 equals x over 4. X over 4 is the same as x divided by 4, so I'm going to multiply by 4. And we get 16 equals x. I could plug this in and check. 16 divided by 4 is 4, plus 5 is 9. Lastly, let's evaluate functions given a graph. So in example 10, the function d of t represents Linda's distance from home after t hours on a long bike ride. Find and interpret each of the following. So in these problems A through D, I am giving you a number. If it's inside the parentheses, let's say d of x, that means all of these numbers, I'm giving you x and I want you to find y. On a graph, x is down here. Okay, so I'm giving you x. That means I want you to find when x is equal to 2, what is y equal to on this graph? So let's go up. At 2, y is equal to 4. This point, right? At d equals 0, that's down here on the x, y is equal to 0. At x equal to 5, so I said d equal to 0, but when x equals 0, when x equals to 5, that's here. And I'm going to go up, find it, and it's about 5.5, between 5 and 6. I can't take points off if you're not sure, if I don't give you a very clear answer. So take an estimate, you'll be fine. And at x equal to 10, y is equal to 0. In the following problems here, find t when d of t, which is y, equals 0. So I'm giving you y, and you need to find x. So if y is equal to 0, this is my y here. That means down here, that's y equals 0. You guys see how like this is a point where it's 0? That's when 0 happens on the y. But you do have to travel all the way across and see that there's another point. So at time 0 and time 10, the distance from home is 0, right? So after 0 hours and after 10 hours, Linda is back home. Find t, at what time is she a distance of 4 miles away? Okay, so she's 4 miles away from, let's see, 2 to 3 hours. Do you see that? It's like this whole distance, 2 to 3 hours, and after 9 hours. Find t when d of t equals to 10. Well, is she ever 10 miles away from home? Never. That's no solution. Hopefully that helped. Clarify any questions. Let me know if you have any further questions.